hear me, let me know. I think I don't need the microphone. My talk is about document rewriting. Basically, problem of you have a document in a specific format, probably some years old, and you want to convert it, rewrite it to some other market. My title in the system conference was textual document rewriting, or when substitutions are not enough. The problem is that probably we don't want to just make a global substitution. We want something a little more complicated. Let's see what it means. What was my motivation? Basically, if you have a known file format, you have hundreds of models to parse it. If you have XML, you have these two heavy models to parse it, and then hundreds of models to use these engines and help you parse the documents. If you have databases, you have all DBA models. If you have spreadsheets, you have also models for that. You have for YAML, you have for Johnson. But if you have a document that you prepared some years ago when no JSON was available, when YAML was available, and you invented your own syntax, okay? And now probably you want to convert it to other formats, say HTML, say XML, say whatever. You have two main solutions. One is to write your own parser using parser technologies like parse regression, parse YAP, parse AYAP, or any other parse model. But that is sometimes quite complicated, especially if you don't know much of parsing, grammars, and so on. The other option is to parse using regular expressions. When you use a bunch of regular expressions, you do matching to some specific parts and try to rewrite the parts. And this is my approach for this presentation. So we want to transform documents from one format to, for example, XML, and you want to use regular expressions. We all know that regular expressions are powerful, but unfortunately they can't do everything without some kind of algorithm. Okay? You can't do simple document transformation with simply one or two global substitutions. Okay? You need to have some algorithm that validates if the transformation is going on, if some portion of the document can be or not curated. So, transformation substitutions on different points of the document can be tricky. Probably you have different zones on the document. Some of those places regular expressions can match, and you can use that regular expression to rewrite. And in other places of the document, you can use that regular expressions to rewrite. Okay? So probably you have zones where the regular expressions can be used. The textual rewriting systems can help. So what are textual rewriting systems? Basically, there are a bunch of rules, and each rule is defined by a pattern, regular expression, a restriction, basically some for code that evaluates over that pattern and returns a Boolean value that says, okay, I can apply this rule, or no, I can't apply this rule, and an action that can be simply a string that you are substituting, can be for code to write anything. So basically, if you look to this is practically global substitution. You have a pattern, you have an action. We just have one more restriction that you can put, of course, in the evaluate part of the substitution, but in this case we have it by itself in a specific location. And with that kind of structure, we developed a model named text-write rules that accepts a bunch of rules of this type and rewrites documents. How it works? It has, first forget that. It is in parallel, of course. It was why, not just because vocabulary expressions are powerful and because it's reflexive, but also because we like parallel. And this model supports different approaches to rewrite the documents. Two main algorithms that I will explain. Fixed point writing approach and sliding cursor writing approach. And it can also be used as a lexical analyzer approach if you want to write parsers using parsia, for instance. And other fusion from the block, so you can change it whenever I want. So, the model supports two writing approaches, and they are useful for different kinds of problems. The first is fixed point approach, and basically the name is cloned by the mathematic approach that want to approximate a function. You'll call it over and over result until there are no difference or no big difference in the result. Okay? That is fixed point function. This kind is quite similar. Lastly, we have a sequence of rewriting rules. We will try to apply them over and over again until no more rule can be applied to the document. Okay? So the rules are sorted in the order you want. The first rule is applied. If it can be applied again, it will be applied until no more is applied. When no more can be applied, the second rule is applied, and then the first rule is tried again. Okay? So it starts always in the beginning, trying to apply the rules. When someone match starts again in the beginning. It ends when no more rules can be applied, or when it reaches a specific rule that says, hey, finish. The other, okay, first example and stupid example. Not here, but basically it's a global substitution to substitute simple emails by either email. Okay? Of course, if you want to do this, you don't use the correct system. It was just a stupid example. Okay? Basically, syntax is rule, name of the rule system, the bunch of rules that you want to apply, and rules. And this will generate code on the fly to be used. I will give some more examples later. The other approach is sliding cursor approach. Basically, the other approach has a main problem. That is, if you write something and it is already ready, so you want that as the output, but another rule match that portion and writes it, you are messing the result that was already prepared. So the sliding cursor approach tries to rewrite from left to right, and every time some piece of the text was rewritten, place the cursor after it, and tries to rewrite at the right. Okay? So basically, it works in the same sense. It applies the rules in the same order. Every time a rule applies, the cursor is moved to the front of the writing portion, and it is tried again to rewrite. It's finished when the cursor reaches the end of the text. So, a simple example would be a word translator that says, okay, I match a word, I check in my dictionary if that word is in my dictionary. If it is, I translate it. Okay? And it works like this below. Of course, the underscore is not my cursor, okay? My cursor is some strange character that is not printed. But this shape is great to simulate the approach, okay? Cursor is placed in the front, it matches latest, it translates, puts cursor in the middle, translates, and when the rules on this approach does not match, the system automatically skips one shader at a time. Okay? It can be configured to skip one word at a time as well. Okay, what kind of rules can we write in this system? Some simple rules only, and you can hit parallel if you are interested. First one is simple substitution. to have a pattern when a string is substituted. You can have evaluation code, of course. So you put an E in the row and it will evaluate for code. You can have a row with only with right hand side to initialize a string. Okay, if you want to do something before trying to apply the rules, you can do in this block of code. Basically, to change $_. And you can have another rule that is if you can find a pattern and followed by that hand, then finish the tracking system. Doesn't try to rewrite it more. And of course, all these rules support curly case. Okay? Any rule you can put exclamation mark and some circle to validate if the pattern can be considered a pure pattern or if it's a false positive. Okay? So you can use the usual grabbing parentheses of $1 or $2. Okay. To give an example of what I can do with this and why we are using this. We have a poorly notated text file. It was a dictionary, old Portuguese dictionary, and we wanted to make XML. Why? Because there is a standard name of tape, technical initiative, that has a well structured for dictionaries, so we want to convert. So basically, not need to read in Portuguese, so not a big problem. Basically, we have in the left side one entry of the dictionary, so one word and definition, etc. We have in this right side the same entry, but in tape. So it is easy to notice that XML is very verbose, but what I want to stress is that the amount of notation is quite different. We have on that side only some stars, so let's see, and the scores. In this right-hand side we have much more information. With just a few substitutions we weren't able to do this transformation. It's not easy. So what was our approach? Basically, we have a tracking system in 4 steps. The first one uses a few tables of specific words that are covered in the dictionary. For instance, entry genres, that is, if that is a word that is used only in formal environment, it's used in formal environment, etc. Domains, if it is mathematics, physics, or whatever. And another table that I forgot there, that is geographic zones. Okay? Portugal, Brazil, city of Portugal, for instance. So this is also my first step, was to construct this table systematically. It wasn't possible to do much automatically. And then, the first step, and I know that rule is not readable, the idea is that we have a bunch of tools that tries to rewrite that asterisks and underscores in something that is not yet my final XML. It's just trying to annotate something more than it is as in the beginning. Then, for the second step, try to match some of that XML that was already created and try to refer some more information on that dictionary. Okay? So the first step was to mark clearly some zones, and the second step is go to that zone, and now we know that we can apply the rules in that place. And final was just to correct some XML that wasn't correctly formed, because the dictionary entries are not regular. You can have, for instance, some